All right, before we get going too much today, let me just go over a couple of things. One is, here's Lexi and Seth. Okay, just a couple of things. Last week was beginning of the second half of the term. So they required us to turn in by Friday midterm progress reports. Okay? I think all present probably were in pretty good shape. The people who I had to turn in something on were those who have had a long string of absences. That meant they hadn't turned in completed the second test, or, some of them not even the second quiz. So, again, preaching to the choir here, y'all are in pretty good shape. Ariana's here. If I can find you, there you are. Okay. So, the rest of you, I think, are in pretty good shape as far as midterm progress reports. But if you hear anyone screaming and hollering that they got a reported D at midterm, that's why, because they hadn't taken the second test. Okay. Next. Because of my doctor's appointment last week, I still have one more 15-minute adjustment to my office hours. Normally, I'm in the office from 8 in the morning until close to 8:30 when my first class starts, Monday through Thursday. However, tomorrow, because this is my third 15-minute increment, we missed 45 minutes of class on Tuesday, so I made up 15 on Tuesday by starting early, 15 on Thursday by starting early, and we'll do 15 tomorrow, starting early. Okay, this is Saya? No, this is Seth. Okay. Sorry. Drew's here. Okay. So, tomorrow morning I won't be in the office as early an hour as I normally would be, because we'll be starting class at 8:15 rather than 8:30. But that's the last, and we'll be caught up by then. Not that I have that many of you looking for me at 8 in the morning, but in case you were to try it tomorrow, I've got to be set up and start the class by 8:15. All right, any questions on anything we've covered so far, or any questions in general? If not, we're in Module 12, which is Rational Expressions, Section 12.4, which is Equations Containing Fractions, and we're at the bottom of Module 12, page 19, and it's this figure here, or one somewhat similar to it. It's not the same figure, okay? So I think we need to do the figure that's in the text first, and then we'll do this figure, which is the focus on the next page. So let's back off a moment here. I was thinking this is the same figure. It's not. We'll get to this figure later. Let's see if we can. That doesn't look like anything's going to give us more room than this will. All right, let me get my pen set up for the dark color. All right, and here's Gary. All right, anyone else come in 6 o'clock? Okay. We're at bottom of page 19 in Module 12. I don't know what's happening, but it just keeps flickering weirdly. Okay? Here's a figure. It's similar to this one. What in the world is going on here? Okay. Probably has something to do with my dragging the computer through the ground a few weeks ago, but we don't know. Emmett decided to show today. If I can find you, here you are. Okay. All right. Okay. Bottom of page 19 in Module 12, here we have a figure. Somewhat of a horizontal line there, going from A to C, with a vertical line going down here from C to D, a diagonal line going here. This isn't to scale. We'll call this B, and they're not straight lines, but forget that. And we'll go here another horizontal line from D to B. This in the middle we're going to call O. Okay. Now, suppose, just use your imagination, that those are all straight lines. Okay? And two of them are horizontal, one's vertical. I hope you can figure out which ones those are. And the other one is a straight diagonal line. That really requires some imagination. Okay, here are some dimensions they give us. 4 centimeters up here, A to C. 3 centimeters here, obviously mine's not to scale, from O to C. And 7 centimeters down here, which is D to B. Okay, this is a perpendicular right angle, that's perpendicular right angle. Okay, now, they do show one other feature of this figure, okay? And that feature is this. Whenever you have two lines that cross, the alternating angles have to be equal, okay? So that means this angle they call X and this angle Y have to be equal to each other. So don't have much room here. That's your X. And there's your Y, okay? Now, based on that, what do we know? What are they asking for? That would be the good thing. Or they just wanted to analyze the figure. Oh, find DO. That's what we're looking for. Find DO. There it is. Okay, no, we found it. Okay. How do we determine the length of DO? Second? Didn't last time we talk about, I know we talked about similar triangles, and we talked about equations that contain fractions, so let's phrase it in those terms. So what do we know? We know that this angle, okay, we know more about this upper little triangle than we know about the lower big triangle, right? We know two sides, and we know something about an angle. Down here we only know one side with the same amount of knowledge or unknowledge that we have about that angle. Okay? Now, since these two angles are equal, these two angles are equal, guess what? This angle and that angle have to be equal because the sum of the three angles of any triangle is 180 degrees, exactly. Okay, now we don't need to know this angle. We don't know any one. We do know that one and this one. So if the angles are all equal, these are what we call similar triangles. Okay? So we need to determine our similar sides. Okay? What do you think is the side that's similar to OB, for instance? It's obstetrician. No. Okay, what is similar side to that? That would be AO. Okay? Well, we're not really interested in that one, but those would be similar sides. Let's pick a side that we do know, the similar sides that we do know. Do we see one? AC and BD. We know the ratio or the fraction of those two sides. And since those two sides are similar, these two must be 2. So the thing we're looking for, OD, has to be similar to this. Now, obviously mine's not drawn to scale, but I think you can see the connection here. How would you set that up? Any ideas? None whatsoever. Okay. How about something like the ratio of OD, which we're looking for, okay, to 3 is the same as the ratio of 7 to 4, right? The ratios of the similar sides have to be the same. The ratio of this to that is the ratio of this to that. The horizontal sides to each other. But with the bigger one on top, if we put the bigger one on top here, then we must put the bigger one on top there. Can you solve that proportion? What's the technique? Y'all know from earlier classes? Pretty standard and useful, very useful technique. Y'all ever heard of two ratios equal to each other as proportion? To solve a proportion, you cross multiply. Ever heard of that? If you haven't, you've heard of it now. Okay, so what does that mean? That 4 times OD, which is what we're looking for, is equal to, say again? 21. So how do we solve for OD? Divide by 4. Excellent. Okay. So this would be OD is equal to 21/4 is a perfectly good answer. If you don't like improper fractions and prefer mixed numbers, which there's no reason to, but you could, 5 1/4. If you don't like either one of those and you want to write it as decimal, 5.25. All those are perfectly correct, acceptable answers. Now, my guess is the book only lists one, okay? And let's see what they do. Oh, they put the decimal. I would have sworn they would have gone with the improper fraction. But you see, if I had put the improper fraction on advanced web assign, wrong answer, where it would have been a completely correct answer, okay? So I was just guessing that's the form they wanted it. But I guessed wrong. They wanted it in that form. Who cares? If you get it in correct form, you get credit for it. And I'm grading, not when WebAssign is, okay? That's one reason I don't like WebAssign. WebAssign has some great features, has tutorials, it has worked out solutions. I'd say use it if you like that kind of stuff, but go with it. All right. Any questions on that? Do you see how that works? Ratios of similar sides in similar triangles have to be equal. The ratio of the similar angles would have to be equal. Now, we don't know enough about any of those to come up with the angles. All we know is one angle. We need to have information on two. We know these two are equal. That's what made them similar triangles, but we don't know what those measures were. If we did know that, then we would know this and that and know everything we needed. Okay? Do another one? Yeah. Okay, let's do the one that's at the figure right here.
So what was CO again?
What was DO or OD? Which was it? They may have said DO. Oh, yes, it was DO. They didn't like ODs.
He said CO.
Press the funny answer.
DO is the distance between D and O. I was saying OD is DO.
Okay, but the problem on the board says find CO.
Yes, I know. And DO and OD are the same thing. You're going from this point to this point or that point to that point. You only talk about the distance. Same distance between O and D as there is between
Okay,
D
so
and O.
5.25 is also CO.
Is that on up there?
Yes.
Well, let's see what it is. We haven't done that.
We're not doing that one.
What's that? We were doing.
We weren't doing that one, were we?
No, we weren't doing that.
Okay, I'm sorry.
Thank you.
Oh, you said CO.
Yeah, I'm sorry.
Okay, I know you're all. No, I'm all right, never mind. Yeah, sorry, we were doing this one, which looks a lot like it, but is not, okay? So, ready for me to erase that one? No? Okay. Too bad. Okay. All right. Now let's do the one that's on the board. in the figure at the right, and this, by the way, is on page 18 of Module 12. And let's see. And is it, remind me of your name, please? Huh? That's page. Okay. There you go. All right. Anyone else come in since I called roll? I almost missed seeing her, so I could have missed some others. Okay. We're on in Module 12, page 18 in Module 12, I didn't turn the page. So page 20 in Module 12, the focus just about a little above the middle of the page. And it's here on the board as well. In the figure at the right, AB is parallel to DC. Okay? Let's assume they're both horizontal. AD, wait, so I said that one, and angles B and D are right angles. B and D are right angles. So we're going to assume those are horizontal, that's vertical, that would make those right angles. You don't have to make that assumption, but it's easier to deal with. Okay? Now, they tell us that AB is 12 meters. So that is a length that represents 12 meters. Obviously, that's not 12 meters, but it represents 12 meters. CD, that's the top one, is 4 meters, or represents 4 meters. Okay? And AC, woo, that's the one from here to there. This is 18 meters. Okay. It says find the commanding officer. Find CO. Okay. So this is the one we're looking for here. There's the unknown. All right. Now, what can you tell me first about the figure? Anything you know right off the top? They told us that the line BD is at right angles to those two bases. Okay? And if that's at right angle to the two bases, well, whether it is or not, anytime you have two intersecting lines, what can you tell me about the alternate angles? Those are equal. So whatever they are, this angle is equal to that angle. Okay? Whatever they are, those two angles are equal. Now, we don't know much about them, but we do know what B and D are, right angles. And we know that those two angles are equal to each other. So therefore, these two have to be equal to each other. One angle at C and an angle at A and an angle at C have to be equal. So that makes these, what kind of triangles? Not quite the same, but similar triangles, exactly. And what can you tell me about similar triangles? They usually called corresponding sides have the same ratio. All the corresponding sides have the same ratio. We do know one set of corresponding sides. What are they? Only two we've got marked, right? Oh, there we got one more mark, so that's not. Those two horizontal sides, we know the ratio between them. And by the way, this one's really easy. I didn't notice the other. No, the other one was definitely not so easy. What is the ratio between those two? Say again? 3 to 1, excellent. With the larger triangle being 3 times the length of the smaller. Okay? So that makes this problem pretty easy. Now we're looking for CO, commanding officer. Okay? We don't know its corresponding side, AO, do we? What do we know? AD. AC, alternating current, okay? That is 18, okay? Now, that's the unknown. CO is the unknown. That has to be similar to this side right here. And can someone tell me what this side would be? Let's pick a value for this one. We could call it CO if you want to, or we could pick a value. X, Y, Z, P, R, Q, A, B, C, whatever you want to choose. What size, what you want to choose that? You want CO or something else? What are you more familiar or comfortable with? CO? Okay. So CO is what we're looking for. If this were to go in the name CO, okay, that's what they asked for. Okay, find CO. There it is. Okay. Now, if we are going to find CO, and we're going to name that CO, CO if you want to, okay? Now, what would the length of this side be? We need to know that. We know something about it, don't we? What do we know about it? We know the overall length, and we've already designated what the shorter length is. So what do we know about this length? Okay, AO, which is 18, minus CO, isn't it? It's that long length. Okay, we're looking for this length. It's that length minus this one, right? Okay, and this length we named as CO. Y'all chose the name for it. Okay. So it's 18 minus CO. Now we can set up our proportion. Okay? Now, the trouble is we have the variable in two places. And what are they? What's our proportion then? Pick any ratio you know, CD to AB or whatever, and the one you're looking for, CO to 18 minus CO. Those have to be equal, right? So CO is to 18 minus CO as what? 4 is to 12, right? Because you do little to big is little to big, okay? If you're doing the little triangle there, CO is to 18 minus CO, because those are your similar sides there, as 4 is to 12, those are the similar sides there. Have to keep the triangles in the right order, okay? Now, just to make things easier, we've already said that's the same as 1 to 3. So let's forget this middle one with the big numbers in it. Let's just go with the smaller one, which is easy, right? What does that give us? How do you solve a proportion? Cross multiply. That would be 3CO is equal to 18 minus CO. And now, how do we solve for CO? That's the first thing we got to do. Get them both on the same side. So let's add CO to both sides. Okay. And how many do we wind up with here? 4CO is equal to, these add to 0, 18. Right? Any questions on that? Yeah or nay? Okay? And then we do what? Divide by 4. And that would give us either 9/2 or 4 1/2 or 4.5. Now, and this would be in meters. They gave us units on this one, so let's keep up with the units. 4.5 meters. Time out. Let's see if that makes sense. Okay? If CO is indeed 4.5 meters, number one, that's longer than that. Does that make sense? Yeah, why? Because this is the hypotenuse. The hypotenuse is always longer than either of the two sides. That part makes sense. Okay? if this is 4.5 centimeters and the whole thing is 18, what would make this one right here? 18 minus 4.5, which would be? Say again? 13.5? Is that what I heard? Say yes? Okay, good. I thought I did. Okay. 13.5. Okay. And does that make sense? Yes, 13.5 is longer than this. Okay. And it's longer than that. Everything looks like it makes sense. That doesn't guarantee it's right, but at least it makes sense. You're in the right ballpark. Okay. Remind me? Johnson? Okay. Tightly, right? All right. Okay. Has anyone else come in since I called roll when I was up here talking to the board or something? Okay. All right. That's how we did it. You want to see how they do it? This is the focus on page 20 in module 12. Okay. All right, for me to erase? Yay or nay? At least one still writing. Got it? No, still writing. Okay. All right. Okay. All right. Let's see how they do it. Strategy. Okay. The triangle AOB, that's the grid going down here, is similar to the triangle COD, charge on delivery. Okay. And here's sine. Got to find you. There you are. All right. Does anyone else come in since I called it off? Okay. So the lower, larger triangle here is similar to that one because 1, 2, and therefore all three of the angles are equal to each other. They must be similar. So we need to solve a proportion to find CO. Okay. Now, they gave us the horizontal line here as 12, the horizontal line here as 4, so we know those two, and there's Pablo. All right. And we need to find a proportion that contains CO. Well, there's CO. Its similar side is AO. Okay? But we don't know AO. They told us AC, but if we designate this, they designated it X. You could have done that. You could have named it anything you wanted to. Fred would have been fine, whatever. So if this is X, this is 18, then this AO would be 18 minus X. So that's your AO. Now we have two ratios. CD is to AB as CO is to AO. Okay? And once we have those, we can fill in the numbers. And I think they did it the difficult way. 4 is to 12, which we said is X is to 18 minus X. We just use COs there. And I bet you what they're going to do is multiply by least common denominators, which is perfectly legitimate and correct and doable. Remind me? Kayla? Okay. Kayla Stinson, right? Okay. All right. Anyone else come in since the called roll? All right. Now they did it what I consider sort of the hard way, the long way. They got least common denominators, which are perfectly fine. Multiply both sides of the equation by least common. By the way, the least common denominator is the product of those two. Multiply this by that and that by that. Okay? Here the 12s go out. And you have 4 times 18 minus x. And over here the 18s minus x's go out. And you have 12x. So you have 12x on this side and 4 times 18 minus 4x on this side. Why didn't they go on to reduce the fraction? They like big numbers, obviously. Okay? So that gave them 18 minus x times 4. That's all that's left. Here, I'll show you. Here the 12s go out, and here the 18 minus x's go out. Okay? So that gave them 18 minus x times 4 is equal to 12 times x. Okay? Now, multiplying through, boy, they like to do it. They're not lazy enough, do you think? I think not. Okay? So 4 times 18 is 72 minus 4x is equal to 12x. And then what would you do there? Add 4x to both sides, and you get 72 is equal to 16x. And then divide by 16, and that gives you 4.5. I bet you they used the calculator. Lazy thing. Okay, so the length of CO was 4.5, which is exactly the same thing we got, only we did it much easier fashion, I think. But you don't have to do it. If this is what you see and like and understand, go for it, okay? It's absolutely correct. All right, any questions on it? Everybody got it? Now, the least common denominator thing is a good thing to do, but notice it gives you the same result as if you had cross-multiplied. So see what you got there? 4 times 18 minus x, 12 times x. If you go back to your proportion, your proportion here, you get 4 times 18 minus x is equal to 12x. You get the same thing, you just cut the least common denominator part, all that multiplying part, canceling out part, dividing out part, it goes straight to the result. Now, that only works if it's a proportion. One ratio equals another ratio. If you don't have that, you cannot use the cross multiplication. Okay? Has to be ratio equal ratio. This is something divided, that's something divided. But it works. Okay. Any questions on that? All right. That was check your understanding. No, that was your focus. After that, as a check your understanding 3, please do that as soon as you can outside of class. As soon as you get out of class and have some free time, do it. Okay? Then there are 4 practice problems. I'm sorry they only give you 4. Please do those. Do all 4 just to get the practice of doing them. All right. Any questions? All right. I have a feeling that's the last slide in the set, and sure enough it was. So let's discard that. Any questions on 12.4B? Okay. Whoops. Wrong thing. Okay, let's go to 12.5A, which is the only 12.5 we've got. All right, we're back. Module 12 is rational expressions, still in that, and 12.5 is variation. Okay. Now, this will harken back to something we were just doing in a very, very similar fashion, I hope. If not, I'll show you. Okay. We will solve 2 types of variation. One is direct and one is inverse. Does anyone want to hazard a guess of what we mean by direct variation? Anybody? Okay. Let's say we were driving from here to Tuscaloosa. Okay? If we were driving at a constant speed, which once you get on the interstate, you can pretty much do, right? As long as there's no bad traffic. Would you say that the time that you traveled is proportional to the distance you traveled? absolutely. If you're going at a constant speed, the longer you travel, the further you go. The shorter time you travel, the shorter distance you go, right? That's a direct variation. You do one thing to one variable, same type of thing is done to the other. Whereas inverse variation is not quite the same, okay? Let's say that we were traveling from here to Tuscaloosa, and that distance is fixed, right? So let's say that we were driving at a slow speed. What would that do to the time that it took us to get there? Take it longer. This time would increase. Decrease the velocity or the speed, you increase the time. But if you increase the velocity, you decrease the time. That's inverse variation. One goes up, the other goes down. Does that make sense? Okay? So that's samples of direct and inverse variation. Many important relationships in business, in science, in engineering, all kinds of areas involve quantities that are directly proportional. In medicine, in all sorts of areas, they involve quantities that are directly proportional. That is, an increase in one quantity leads to a proportional increase in the other quantity. Okay? And here is how you write a proportion. Okay? We're saying something on the order of, I need to get my pen back. Okay. What's that? Oh, no. Okay. That y is proportional to x. That's how we write proportionality. Now, it sort of looks like an alpha symbol. It sort of looks like a fish symbol. Reminds me of a goldfish, but I think in terms of food. But that's a proportionality. It's not an equation, okay? To make a proportionality into an equation, just change the proportion symbol to equal k. So y is equal to kx. This becomes equal k, and that's exactly what we've got here. What is k? Not necessarily k over there. It's the proportionality constant. The constant of variation. There's a variation, I'm saying proportion, okay? Proportionality constant or the constant variation, okay? Now, that equation, y is equal to kx, is a general form for a direct variation equation, and it says y varies directly as x, which is what that says, and that also says equals some proportionality or constant variation times x. Now, if I'm wanting to say that, I'm going to write it like this. If I write it like that, it equals to the constant variation constant times x. I don't know why they mix up the words that way. Okay? Not very precise. The math should be more precise. Okay. Still a few people writing, so I'll let them finish. A lot of words on this slide. Constant of variation, also called a proportional constant or constant proportionality, or there's lots of names you can give for it. Okay? Everybody got it? Okay. Now, direct variation, the equation y is equal to kx states that y varies directly as x, where k is the constant of variation. Okay? Also called the proportionality constant. Okay? Now, there's a focus already. I bet you we're not quite ready for the focus. Let's see. Yep, we are. Okay? They go straight through this. Yep, same one. Find the constant of variation if y varies directly as x and y is equal to 35 when x is equal to 5. Okay? Now, write down what we mean when we say y varies directly as x. How would you write that mathematically? That's a lot of long words. Math makes it short, sweet, directly to the point. How would you write y varies directly as x without using words? Y Hint, hint. Equals kx. Varies directly as or is equal to kx. Isn't math much more direct? Shorthand doesn't need as many words to do. Y is equal to kx. Okay? Now, that is what they tell us, that y varies directly as x. Now, they also tell us when y is equal to 35, put in a 35 for y, that's equal to k times x, but x is 5. What is k? Really hard to do, isn't it? That is one of the ugliest 3s I've ever seen. So let me try to correct that 3 a little bit. Okay. Now, how do you find k? Divide both sides by 5. That gets rid of the k on this side, and that gives us k equal, second, 7. Excellent. So k is your variation, constant variation. Okay? Okay, so we did the first part. We found the constant variation k. There it is, 7. Okay? Now, the second part says, then write the specific direct variation equation that relates y and x. So go back to your original. Y is equal to, and what's k? 7x. Boy, they make it seem like such a to-do, but it's a real simple equation, right? Y varies directly as x. If you increase x, you're going to increase y big time by 7 times. If you decrease y, x, you're going to decrease y by 1/7 as much, okay? So sure enough, that's a direct variation. Make sense? All right, can I erase? Say again? What's that? Yeah, there's 2 answers. First, it says find the constant variation. That's what we did there, k equals 7. And then it says, then write the specific variation equation. There it is, y is equal to 7x. Second? Yeah, k is the constant variation. Yeah. Everybody got it? Okay. Oh. Good deal. Thank you. Giving me more to grade. Thank you very much. All right, to erase? No, people still writing? Okay. All right. All right. Now, let's see how they did it. Find the constant variation, replace y with 35, x with 5. In the general form of the direct variation equation, y is equal to kx. That's where we started. Plug in the 35 for y, 5 for x, solve for k. Exactly what we did, and they didn't show how to do it. And to write the specific direct variation equation, replace k with the value you got in the general variation. Wow. A lot of words, right? So here's how they did it. Y is equal to kx. There's your general form. Plug in what you know. Y is equal to 35. When x is equal to 5. From that, you can determine k is equal to 7. Exactly like you did. Then plug that back into your original equation. Y is equal to, the constant variation is 7. Yay, okay. That answers the first question, or first directive. And then the second part is write that y is equal to 7x. Put the 7 in instead of your k. And you got it. There's your answer. Any questions? Make sense? Okay. Can I move on? Okay. Oh, the direct variation equation is y is equal to 7x, as if they hadn't written it already. Okay. All right, now we'll move on. Now, There is a check your understanding right under that one. And they skip the next focus. You want to do the next focus? Okay, let's do the next focus. Good one. Okay, really has a problem here. The amount A, I told you this applied to medicine, of a medication prescribed for a person is directly related to the person's weight. How would you say that? A is equal to KW. Proportional to is equal K. Always is equal K. K is some constant. Okay? So that tells you that. Directly related to the person's weight is equal to K. So, they've got an error here, but we'll let them get by with it because this is a math book. They say for a 50 kilogram person, guess what 50 kilograms is? The mass of the person, not the weight. This is now a physics class, okay? There is a difference, okay? But we're going to let them get by with it because they're proportional to each other, too, okay? So, we'll assume incorrectly that's the weight. So, we'll put 50 in for the weight. And we know the K is going to be there. The amount of medication is 2 milliliters. Okay? Now, I don't like that they use little l for liter because that looks a lot like a 1, but we'll let them get by with that too. I'm going to put capital L. What is your K in this case? How would we get it? Divide both sides by 50. Okay? Okay, now I'm not going to carry around the units anymore, so I'll just throw them out. This will be 1 to 25. Okay, so K is equal to 1/25. Okay? How many milliliters of medication are required if the person weighs or has a mass of 75 kilograms? So how would we find that out? What are we looking for? Say again? Looking for what? I heard someone say something, I just can't make it out. Please help me. What were you saying? Yeah, say it again. Sam? Okay, no, okay. We're looking for the amount of medication, which is A. And that's equal to what? That's equal to K, but K is 1/25. Times his weight. And they use mass for weight, and what is that? 75 kilograms. Okay, I'm not going to put the units in because that might get confusing. Okay, that's going to be pretty easy. What do we do? A is equal to? Pretty easy. Yes. 25 will go into 25 once, so it'll go into 75 3 times. That would be 3 milliliters. That's how much medication you give a 75 kilogram person. Okay? And sure enough, they got it right too. Good for them. Okay? And there's a check your understanding that goes along with that one as well. Does that make sense? Pretty easy. Oh, I just noticed they wrote it in decimals. Guess what? It works either way. I found the fraction to work very easily with decimals. I might have even had to have a calculator for that. Who wants a calculator? Okay. Never mind. Okay. All right. Can I erase this and go to the next? Okay, actually, I'm not going to erase. I'm just going to go to the next. All right, here we go. Two quantities are inversely proportional if an increase to one leads to a decrease in the other one, a proportional decrease in the other quantity. or if a decrease in one leads to an increase, proportional increase in the other. An inverse variation is one that can be written in the form y is equal to or proportional to 1 over x, which proportional to means equal k over x. K is, again, your proportionality constant, okay, or constant variation, okay? The equation y is equal to k over x is the general form for an inverse variation equation. It's read, you read it as y is equal to k over x. It means y varies inversely as x. Reason inversely? Because it's an inverted form, okay? And think about this with fractions. If you increase the denominator of a fraction, what are you doing to the other side? Decreasing, because 1/2 is more than 1/3, which is more than 1/4, which is more than 1/5. So if you increase the denominator, you decrease the amount on the other side. So that's the inverse variation, okay? So y is equal to k over x. There's your inverse variation. It is important to note that the direct variation equation, y is equal to kx, as the quantity increases, y increases. As x increases, y increases. We already said that. All right. Inverse is the other way. So in the inverse equation, y is equal to k over x. As the quantity x increases, y decreases. As x decreases, y increases. We've said it several times now. The equation y is equal to k over x states that y varies inversely as x. That's the fact that one's in the numerator, one's in the denominator on opposite sides of the equal sign. The equal k says it's that tells you the constant variation. That equation k again is constant variation. So is proportional to is always translated equal k. Okay. If direct translation, the direct variation, the k is multiplied by x. If it's inverse multiplication, the k is divided by x. Okay. So here's a focus. Find the constant, blah, 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 blah. Yeah, that's the one that's in the text next. Find the constant variation if y varies inversely as x, and y is equal to 30 when x is equal to 10. Then write the specific inverse variation, that equation that relates y and x. So first thing we do is look for what? Constant variation. Good. How'd you figure that out? Okay. Now, what do we usually let represent the constant variation? K. Okay. And by the way, you know why K rather than C? Probably developed by the Germans, and they spell K with a K, constant with a K. Okay. I don't know if that's true, but I made it up. Okay. So, anyway, what's that?
I think it has more to do with chemistry.
It could be, yeah. Okay. And they were very good chemists. Okay. All right. So find the constant variation if y varies inversely as x. Okay, write the equation that means that. Y varies inversely as x. Y equal to k over x. Perfect. Okay. Now, since you've written that equation, let's plug in what we know about y and x. Y is equal to 30 is equal to k over 10. How are we going to figure out what k is? Say again? Ooh. Say again? Multiply. You got to get rid of that denominator. That's going to be a big number, folks. What's k going to be? K is equal to, say again? You may have said it right. I just can't hear well. Help me. 10 times 30? A little louder? 300. Yes, a big old K there, isn't it? Okay. All right. See if that works. Yeah. 300 divided by 10, sure enough, is 30. So, yep, that seems to be right. Then, okay, we've done the first part. We found the constant variation. There it is. Okay. Then write the specific inverse variation equation that relates y and x. So what would that be again? just like we did before, y is equal to, a little louder, 300. Now we plug that in over x. There it is, 300 divided by x. Okay? Now, here's just a kind of, let me see, does this example work? I think it will. Let's say that's a spring constant, okay? Really stiff spring. And if you stretch the spring, yeah, that won't work. Hang it up. Thought that might be an easy one, but it wouldn't be. Okay, that's direct variation I was thinking of. So that's the focus on the bottom of page 23, moving to the top of 24. And sure enough, that's what they got here. Let's see how they did it. Let's see if they could make it more complicated. Anyone need it up there a little longer? No. Okay. See how they did it. To find the constant variation, replace y with 30 and x with 10 in the general form, which is the first thing you got to determine. So it's the inverse variation, y is equal to k over x. Solve for k. That would be 30 is equal to k over 10. Okay, they haven't done it. They're just talking about it. And then write the specific inverse variation equation, replacing the k with the value you found right there. So that would be y is equal to k over x, exactly like you said. Plugging in 30 and 10 for y and x, then when you go to solve for k, that means multiplying both sides by 10 to isolate the k, and sure enough, that gives you 300 is equal to k. Big old constant. Constant variation is 300, and then your general equation is y is equal to 300 over x, plugging in the k that you determined there in your general equation. Make sense? Pretty exciting stuff, right? All right. So the inverse variation equation is, so write it again, y is equal to 300 over x. Got it? Oh, they say that's the end of the section. Let's see. There is a check your understanding 3, which I suggest you do as soon as you can out of class. And that's a little bit different. Okay? No, it isn't. Yeah, it's very similar. Okay. But then there's another focus they don't show us. So let's back up and do the second focus. I think we need that. Okay? All right. In an automobile cylinder, the volume, V, of the gas varies inversely, is equal to, how did I say vary inversely? K over, and then they say with the pressure of the gas, which is P. Okay? So they gave us new variables, volume and pressure. The volume varies inversely as the pressure. That's true for any, at constant temperatures, that's true. Okay? For any gas, not just in an automobile engine. Okay? Now, given that the temperature does not change, there's what I just said. If the volume of the gas in a cylinder is 300 cubic centimeters, that's going to be the V, 300. Now, leave off the units for now because they may just get confusing. Cubic centimeters, when the pressure equals K over, pressure is 20 pounds per square inch. I said I was going to leave off the units, but let me just ask you, is that a lot of pressure? It sounds like a lot, doesn't it? 20 pounds per square inch. You know what normal atmospheric pressure is? 14.7 pounds per square inch. So that's not a huge amount of pressure, okay? So I was going to do that, but let's just leave off the unit, okay? So that's what they told us. I've lost my place here, okay? What is the, okay, when the pressure is 20 pounds per square inch, What is the volume if the pressure is increased to 80 psi? So now we're looking at a volume, a new volume. V, let's call it V new, is equal to, or when P is 80 psi. 80 pounds per square inch, wasn't it? Yeah, there it is. So P2, or P new, is equal to 80 psi. Okay? How would you approach that problem? You know the volume is proportional to K over P, is inversely proportional to the pressure. So we know when the volume is 300, what was it, cubic centimeters, I think, when the pressure was 20 psi. And frankly, if I was a physicist, which I am, it would sort of grate on me a little bit. Because this, if they measure this in cubic centimeters, that's metric, and this is psi, pounds per square inch, you say the units aren't matching. But guess what? We're just doing this thing. We don't have to have matching units as long as everything we do, if this volume is going to come out in cubic centimeters, not in cubic inches or anything else, because our input is in that. So we can actually get away with not having balancing units. Most of the time in physics, no, you don't even want to try that. But for a simple equation like this, you can. Okay? So, what's the first thing we better do? What have we been doing? A little louder? No, you probably are right. I just can't hear. Come on. Anybody? Find K! Perfect. How do we find K? Absolutely. Okay. Okay, so notice the sound effect. K is equal to 6,000. No, 6,000. Okay. Okay, and then what do we do? Our new volume is equal to the same old K, 6,000, because that's a constant of variation, divided by the new pressure, which is 80. Okay, this is not too hard of a problem to do. We can wipe out 1 0 there. That works. Okay, and then 8 will go into 60. What is that? 7 times. Okay, and 7 times 8 would be 56, and 8 will go in the 40. 8 will go in the 40 5 times. 75 cubic centimeters. Okay, that would be the volume. I think that's what they're asking you. Find the volume when the pressure is increased to 80 psi. 75 cubic centimeters. Okay. Now, I'm not sure why they used an automobile cylinder now, except that that's when it is compressed, and then when you increase the volume, it pushes the cylinder up. You have to assume no change of temperature, remember? Most of the time in an automobile engine, there's going to be a change of temperature, because if that spark plug fire, you're going to have an explosion in there, and the temperature is going to go up. So, but as long as it's a constant temperature or near it, you'd be okay. All right, there is a check your understanding. Oh, let's see, is that all they asked for? Yeah, that's all they said. What is the volume? There it is, 75 cubic centimeters. You don't have to go back and rewrite the equation or something on this one. Check your understanding 4. There is a problem given there. Please do that as soon as you can after class. And then the objective practice problems, they have 5 of them. Please do all 5 of those. And those are all in the solution pages at the end of the module, just on different pages. Okay, why, I don't know. All right, I'm pretty sure that's the last slide on this. Any questions before we leave it? Okay. Sure. What's that? anytime you finish it. So if you finish it today, you can turn it in today. If you finish it on Wednesday, by Wednesday, turn it in on Wednesday. Bring it by my office before then if you want to. Anytime you finish. Okay?
When are we having the test?
Okay, that's just what I was going to say. Technically, it was due, I think, probably today. But, if you aren't finished with it, I want you to finish with it. I don't want you to turn in a partial quiz. I want you to finish the quiz. That's practice problems for the test. So finish the quiz. But get them to me as soon as you can. Now, to answer the next question, which was, let's see how we, here. Throwing money all over the floor. Okay. I have the time right here. Yeah, we got a few more minutes. 12.6 is coming up. I don't think we're going to finish it today. So if we don't finish 12.6 today, we'll finish it on Wednesday. That means stand by for the test next Monday, a week from today. So I've got to have the quizzes in. I want them in Wednesday so I can grade them, and you'll be able to see your results before your test. If you get them to me today or tomorrow, I'll try to get them graded before class so you can see them Wednesday. But the sooner you get them to me is the sooner I can get them graded. Okay, so let's go. Any other questions from current slide? All right, we're still in Module 12, which is still rational expressions. Now we're moving. I thought we just did that. Okay, for some reason it didn't do what it was supposed to. Let's escape there. Let's see if I hit something wrong. I must have. Yes, I hit the wrong one. There we go. Or the pen jumped or something. I'm sorry? I'm sorry, I can't hear. Did someone say something? Oh, okay. It's not to me. Okay, fine. Okay, let's try it again from current slide. I thought something seemed bizarre there. They usually ask for that. We're still in Module 12, Rational Expressions. We're now in 12.6. Our favorite application problems. If I remember from the first test, these were everybody's favorites, weren't they? Not, okay. Please do these. They're a section in the book. You're going to see them on the test, so please work on these. Solve work problems. If a painter can paint a room in 4 hours, then in 1 hour the painter can paint 1/4 of the room. Makes sense, right? The painter's rate of work is 1/4 of a room for each hour. Weird way to say it, but obviously true. The rate of work, that is part of the task, the rate of work is that part of the task that is completed in 1 unit of time. So that's his rate of work. In solving a work problem, the goal is to determine the time it takes to complete a task. That's what we're looking for, time. The basic equation that is used to solve work problems is this. The rate of work is what we're looking for. Is the time work. This is a weirdly stated thing. The basic equation, I'm sorry. That's the time side. The rate of work times the time work equals a part of the task completed. Okay? So if his rate of work is 1/4 of a room per hour, and he works 15 minutes, then that's going to be 1/4 of an hour. So 1/4 of 1/4 would be 1/6 of a room completed in that 15 minutes. So, or if he worked 2 hours, that would be 1/4 times 2 would be 1/2. He'd have half the room completed in 2 hours. So that's how we use this equation. Rate of work times the time work equals a part of the task completed. You know what that's a lot like? The speed that you drive times the time that you drive gives you the distance, right? Speed times time gives you distance. Miles per hour times hours gives you miles. Part of the rate of work, so many rooms per hour, or fractions of room per hour, times the hours gives you how much you completed in that time period. Just like your speed distance problem. Okay? Now, here's a focus. Before we get to the focus, let's do this little example. Let's do it here. That's the only slide they have that has much white space on it. Okay? If the faucet can fill a sink in 6 minutes, let me get my pen back. Oh, are we out? Sorry about that. We'll pick up then next time with this little example right at the bottom of the page. And then we'll move from there.
My research paper, my topic is how nursing interferes with how does the math relate to nursing. Is there like a topic I can use?
That would be perfectly fine.
Okay, because that's
You-
my major.
Okay. Do you know who the first, I consider the first applied statistician was? Florence Nightingale. She used math to convince doctors that they needed to be more sanitary in their treatment of she was dealing with war-type situations, you know, Crimea and some places like that. And she convinced them if they didn't have sanitary conditions, more men were going to die. You know, if they didn't, she came up with all kinds. She used math. Florence Nightingale, the mother of nursing. Yes.
She's a good one.
My mom was a nurse, so I know about Florence Nightingale. Okay. But I'm also a mathematician. I know about Florence Nightingale. She
You
was.
know, fable they used to sing to us as children.
Right.
That came from her.
Look her up.
She's a good one. You'll like her.
I'm going to look her up tonight because I'm trying to go ahead and get my paper done.
Absolutely.
So I don't have to worry about it.
Fantastic idea.
Thank you.
Okay.
Have a good day.
All righty.